Okay, guys, so today we're going to talk about properties of exponents, specifically 0 as an exponent, 1 as an exponent, and negative exponents, okay? So this is 8-1, properties of exponents. Okay, if I ask you guys what 3 squared is, you're all going to tell me it's 9, right? What is 3 to the 0 power? I heard a 1. Any other guesses? What's 3 to the 0? 0 is a very common guess. Any other guesses? No one guesses 3?
I think it's 3.
Okay. So far as potential candidates, we have 1, 0, and 3. Any other ones? Those are usually the 3 most common. Turns out 1 is correct. Turns out anything to the 0 power is 1. So let's jot that down and I'll explain why. So anything, well, there is one exception to that. Anything to the 0 power anything to the 0 power is 1. Let me tell you why, and then I'll tell you what the exception to that rule is, or maybe you can tell me. So, what we are going to learn in this chapter is that when you have 2 numbers that have the same base, which is the large number, right, and then that's the exponent, if you have 2 numbers that have the same base and you're dividing them, you can actually subtract the exponent. So, for example, if I had, say I had 3 to the 4th over 3 to the 3rd, what I can do is I can subtract those two, and 4 minus 3 is just 1, so that's the same thing as 3 to the 1st power. And 3 to the 1st is just 3, right? So, what if I were to have 3 to the 4th over 3 to the 4th? Well, if I apply that same rule, if I subtract those exponents, 4 minus 4 is 0, isn't it? So that would be 3 to the 0 power. However, guys, take a look back at the fraction. When you have the exact same thing on top and bottom, like 5 over 5 or 19 over 19, what is that always? 1. So 3 to the 4th over 3 to the 4th is 1. Okay, so that's how we get 3 to the 0, and this will work for any number. It doesn't have to be 3, right? 19 to the 0 power, same idea. It's going to result in a value of 1. I did say before that there was an exception to this rule. There is one number that you raise to the 0 power that is not 1. Josie?
Is it 0?
Yes. Do you know why? Or do you know what it is? What 0 to the 0 is?
No, it would just be 0.
It is not 0, surprisingly. Nate?
0 over 0 is not 1. 0 over 0 is just
Yeah, he's on the right track there. Guys, if you try and do 0 to the 0 power, 0 to the 0 is not 1. 0 to the 0 is actually, Jack?
It's 0, and isn't that because, like, the exponent means basically just how many times you're multiplying a number by itself. So, say for example, 1 to the 0 power means you're just multiplying 1 0 times by itself, right?
That's a common thought. The problem with that is if I try and apply these same rules to 0 to the 0 power like I did up here, something happens that we're never allowed to have happen. So, for example, if I try and do 0 to the 4th over 0 to the 4th, there's a problem with this.
0's in the denominator.
Exactly. We're never allowed to have 0 in the denominator. When that happens, this is called undefined. So this would be 0 to the 0, but that's undefined. Do you know why that is? Jack?
Just technically speaking, if you were to actually divide it out, it would result in more of like 0.0 repeating, right?
Well, why can't you have it in the denominator, though?
That wouldn't make any sense. I don't really explain it. I just say that you can. You can't have anything out of 0.
Yeah, let me try. Say I had, I think there's, how many of you today? Probably 24. Say I had 24 cookies. Could I break 24 cookies into 24 groups? and therefore I could give each one of you a whole cookie, couldn't I? Okay, say we had 48 kids in here, but I still only had 24 cookies. Can I still break my cookies up into a group and give everybody, they wouldn't get a whole cookie, they'd get a half a cookie, wouldn't they?
Yes.
Okay, let's say I didn't have any cookies. So I had 0 cookies and I wanted to break it into 24 groups to give each of you a part of that. I can do it. You just get 0 cookies, don't you?
Yeah.
So haven't you ever had a tea party? There's no tea in the teapot, people. So it's pretend. You get little crumpets and scones with your tea at the tea party. You remember when you were little? I'm sure you can imagine it, okay? You're sitting around, there's no tea, there's no crumpets, you're just pretending. So I have in front of me a plate of 24 cookies. I'm gonna give you each one of them. Boop, 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 boop. Now you all have 0 cookies. I took 0 and I divided by 24 and the result is 0. Okay, so I can take 0 and divide it by a number. That's having 0 in the numerator and the answer is just 0. I can take 0 cookies and divide it into 48 parts if I had 48 kids in the room, couldn't I? Yeah, I can do that all day long. I can take my 0 cookies and break it into 1,300 parts for everybody in this building. And everybody can have 0 cookies. However, let's imagine I really did have 24 cookies. So, pretend I really do. I wish I had 24 cookies. Pretend these are my cookies. So if I have 24 cookies in my hands, I can do a couple things with them. I can divide it by 24 and give each of you one of them. I could divide it into 48 parts and everyone gets a half. Right? What if there was only 12 people? Couldn't I take my 24 cookies divided by 12 and everybody gets 2, right? What if I was like, you know what, I don't want to share my 24 cookies. I'm going to leave it all in a group for myself. So 24 divided by 1 means that I would get how many cookies? 24, right? Sweet. 24 cookies just for me. However, I cannot take 24 cookies and divide them into 0 groups. Think about that. I can't divide them into no groups at all. That's impossible. This is not Hogwarts. You can't snap your fingers and they disappear. They're always there. You can say, oh, you could burn them. Yeah, okay, now you just got burnt cookies. They didn't disappear. They're there. You could eat them. Okay, well, now they're just in your tummy. It didn't disappear, right? So I can't take things that actually exist and divide them into nothing. Does that kind of make sense? I can divide them by any number I want. Right? I could have 24 cookies, and couldn't I divide it into 24,000 pieces if I wanted? It would just be a really, really tiny little crumb. Yeah, but you could do it in theory. And when we're thinking about just numbers, like I can take 24 and divide it by any number I want to, except 0. So that's why when you divide a number by 0, like we like to joke that, oh, your calculator's going to explode. You can't do that. There's actually a joke. You can't divide by 0, but Chuck Norris can. You know those Chuck Norris jokes? He can't divide by 0 either. But I just want to show you really quick. If you try to on a calculator, so here's just one of our normal 4 functions. If I try and do 8 divided by 0, don't worry, it won't explode. But look what does happen. What happened? Yeah, there's a little E that pops up over here. And every calculator is a little bit different. Here's another one of these AT&T ones. So if I try and do the same thing, so 8 divided by 0 equals, this one actually comes up with the word error. If I try on one of my graphing calculators, I get one of those, like it goes to a whole new screen and it says syntax error or something like that. So every calculator will have some sort of indication to you that you can't do this, but sometimes like a little E like this over on the side, you might not notice. So just be mindful of that. If you ever forgot, if you are allowed to use a calculator, you can just go ahead, try it. But you can do 0 divided by anything. So if I want to do 0 divided by 5, I really do get 0 and there's no error. Because that's allowed. You can take you can take 0 and divide it by any number you want. And you will always get 0 as an answer. Does all of that make sense? Okay, so back to our exponents. That's kind of why 0 to the 0 power is the only number that's not 1. It's what we call undefined, because I cannot divide by 0. Okay? So let's try a couple of things. Let's say I had 14 to the 0 power. What is that going to get me? 1. Let me switch back to black, actually. If I had, what about 1 to the 0? Still 1, right? The only time you're going to have an exception is when it is 0 to the 0 power. Until I try and trick you with this devil snare. What is this? Say I had negative 3 to the 0 power, written in parentheses like you see here. So that's actually really important. I want to bring that up right now while we're talking about exponents. If I want to raise a negative number to an exponent, I have to use parentheses. If I just write negative 3 to the 0 power without parentheses, it's actually a different problem altogether. So if I want you to actually raise a negative number to a power, I have to put it in parentheses. What is this, Tom? Well, can we all agree that's either 1 or negative 1? Yes. Raise your hand if you think it's negative 1. Okay, a couple of you? Positive 1. Well, if you go off of my star up here, anything to the 0 power is 1. It's going to be 1. Doesn't matter if it's positive or negative. Now, I said a moment ago, this is a different problem. What is that, Josie? That's negative 1. Let me explain what's going on here, okay? Yeah, remember in order of operations, doesn't a negative in front of a number just mean that that number is negative 1 times that number? Yeah, so negative 4 is really just negative 1 times 4. That's how we get negative 4. Order of operations says you have to do parentheses, then exponents, then multiply or divide. So, in this case, when it is written like this, what this means is you must do the exponent first. So you have to do 3 to the 0 power first, which is 1, and then take the opposite of it. You will get negative 1. This one little tidbit is what causes the most problems in this whole chapter. So the sooner we get this down pat, the better off we'll be. First of all, do you believe me? I hope so, because I wouldn't lie about this. Okay? I assure you, in fact, oh good, I have a graphing calculator right here. We'll ask our friend, the graphing calculator, what it says about this whole conundrum. Okay, so first what I'm going to do is I'm going to put negative 3 in parentheses. So I've got negative 3, and then when I want to raise something to a power, have you guys seen that symbol before? It's called a caret. Okay. So there is negative 3 in parentheses raised to 0 power. What are we expecting to get as an answer here? Positive 1, right? Let's see. Oh, good. Positive 1. Let's try the same thing, no parentheses. Negative 3 raised to the 0 power. What are we expecting to get here? And in fact, we do. Okay? So when you do not have parentheses around the number, you're going to raise the number to the power and then take the opposite. Okay. Are you ready for a really tough one?
Yes.
All right, let's try this. What if I gave you negative 3 to the 0? What is that going to be? Well, hold on. Think about it. Write down what you think it is. I think we can all probably agree it's either 1 or negative 1, but I want you to stop and think. Take a shot what you think this one would be. Everybody's got an answer? Alec, what'd you say?
Negative 1.
He says negative 1. Raise your hand if you said negative 1. Positive 1? Oh, okay. That's a pretty good split there. So, let's follow order of operations. Inside the parentheses, is there anything to do? No, it's just a negative 3 in there. Nothing to simplify, nowhere to go. So now the next thing I need to do is exponents. So I have, in this case, negative 3 in parentheses being raised to the first power. What is that?
1.
That's positive 1. We talked about that a minute ago. Now, this negative out in front tells me it's negative 1 is the correct answer here.
When you have 2 negatives and it's extra, positive.
Okay, so she raises a good point. Do you hear what she's saying? She's saying, well, you've got negative, negative. And negative with a negative makes a positive. She is right, except for the fact that there's an exponent here. So if you do negative and a negative makes a positive, you're doing the multiplication before the exponent. And we can't do that. Since there's an exponent, you have to take care of that first. Yep.
If there wasn't parentheses, would it be 1?
So you're asking if we did it like this? Like that? Well, the problem with this is that
You could do -1
this, I guess, would be a positive one, but you're never going to see it written that way. We never write two negatives next to each other like this. They would always be separated by parentheses. But what you might see is something like this. What if I wrote it like this? Ooh, how about that one?
That's a 1. Just kidding. Wait,
It's tough,
I got that.
right? These can get tricky.
It's 1.
Follow your order of operations, guys. Inside your innermost parenthesis.
It's 1.
Well,
It's 3.
it's just a 3, right? Your innermost parenthesis is just a 3.
Okay.
Now, the next thing I need to do before I move on, what is this chunk? Because this is inside another set of parentheses. That's -3. So I could rewrite this problem as this. And then, aren't I right back to the problem that we did before?
Yes.
Yeah. So this is actually what? That's a -1. What if I did it this way? Oh no, I already did that. Yeah, okay. I'm happy with this. Does this make sense? Let me try just one. I'll give you maybe 4 of them to try on your own. We'll go easy, medium, hard. Ooh, that's a good one. Oh, I'll have to do the 4th one down here. Try those 4 for me. Yep.
So this one's -7, and then so I just write -1. Then there's a -7 right there. Because like the exponent moves out, so would that be equivalent to like making it positive? Okay.
Perfect. Good. I'm just going to move this up a little bit. Okay, does everybody have an answer for all 4? All right, let's walk our way through. Number 1, we get 1. Everybody's okay with that? All right. Number 2, that's going to be -1. Because remember, first thing you're going to, this is not written with parentheses, so you're going to do 7 to the 0, which is 1. This now means take its opposite. So your correct answer here is -1. Good job. 3, okay. Well, it's either 1 or -1, right? Yeah. So here's how we're going to work this. We have parentheses. So inside the parentheses, there is some work for me to do. Okay? So if I look inside the parentheses, what should the first thing be that I do? 7 to the 0 power, which is 1. And then this means -1. So what I now have inside the parenthesis, that's going to reduce to be -1. Now, what's -1? Now it's a +1. So your final answer for number 3 is in fact a +1. These are
Why was it -1 for negative for the other for the 3 one? Like the example to positive.
No, I'm just kidding, I got negative.
this, okay, the difference between this one here and this one here, this one has the exponent outside the parentheses. Yeah. So one subtle little difference is going to change the whole thing. Okay, and then number 4, we have 2 parts. So let's take a look at, sometimes with these too, if it's helpful for you to just cover up pieces and do one piece at a time, do that. So if I just asked you what that was, you would tell me -1. It's the same thing as question number 2. So hopefully we realize, okay, this chunk right here is just -1. I'm going to multiply it by whatever I get in this chunk over here. And what do I get from that chunk? +1. So I'm going to do a -1 times a +1, which is -1 all day long. So -1 is our correct answer for number 4. Does that make sense? Okay. So we have covered when you have 0 as an exponent, how to handle these negatives. What I'd like to talk about next is negative exponents, okay? So, I'm going to switch to a new sheet of paper. So, it turns out, yes, you can have negative exponents. You can actually have pretty much any exponent you want. Did you know you could have fractional exponents? Yeah, you can. Pretty cool. So, right now, though, we're going to focus mainly on the negative exponents. Let me go back to what I was saying before. Remember how if I had 3 to the 4th over 3 to the 3rd, what did that get us? It was 3 to the 1 because we subtracted those exponents, right? And then we went to 3 to the 4th over 3 to the 4th, and that's how we got 3 to the 0. But since it's the same thing top and bottom, we talked about how that's 1, right? Well, what happens if I keep going and I make the 1 in the denominator bigger? So what if I had 3 to the 4th over 3 to the 5th? Yeah. So this is 3 to the -1 power. What's really going on here, ladies and gentlemen, is if I were to write this out, what's 3 to the 4th really mean?
3 times itself.
4 times, yes, exactly. So here, I'll write it down here. 3 to the 4th over 3 to the 5th. 3 to the 4th is 3 times 3 times 3 times 3. Agreed? Okay. And then in the denominator downstairs, 3 to the 5th, same idea, but I have 5 of them now. Oh, let's have 5. Okay. So what's happening here is that I have 4 of these 3's on top, 5 of them on the bottom, but just like when you were in elementary school, when you realize, oh, hey, look, if I have the same thing on top and bottom, you can reduce this. 3 over 3 is just 1, isn't it? So yeah, I can cancel these out and put a 1 in their place if I wanted. 3 over 3, 3 over 3, 3 over 3. But now I've run out of 3's to cancel, so I have 1 left on the bottom. So, in other words, 3 to the 4th over 3 to the 5th gets me 3 to the -1, but 3 to the -1 is actually equal to 1 over 3 to the 1st power. Does everybody get this chunk, this and this? And you see how I cancel them all out?
I just don't get how you got the fraction and the exponent.
Okay, so, well, what's left in my numerator if I cancel all those 3's out? Well, there's something It's a 1, right? And downstairs, all these are 1s, but 1 times 1 times 1 times 1 times 3 is just 3. Right? Okay, so if I have 3 to the negative 1, that just means that there's 1 3 left in the denominator. Now, I don't expect you to write this out every time. That would be such a waste, but I want you to understand why this rule works. So, if you have, let's say, 3 to the negative 7th power, that's the same thing as what? Yes, 1 over 3 to the 7th. Notice that once I move it to the denominator, the number's not negative anymore. Having a negative exponent means that I now have 3 times itself 7 times in the denominator. So once you move this to the denominator, you don't have negative exponents anymore. One thing throughout this chapter that you're going to want to get in the habit of, we never want to leave our answers with negative exponents. Okay? Just like you don't want to leave a fraction as like 2/4. You would always reduce, right? It's the same idea. So when you have negative exponents, you want to rewrite it so that you don't have negative exponents anymore. Now, one thing I want to make very, 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 very clear. A negative exponent does not mean that the number is negative. Maybe the number is negative, maybe it's not. A negative exponent has nothing to do with the sign of the number. You get what I'm saying? So in other words, 3 to the negative 7th doesn't mean just do 3 to the 7th and make a negative. What? No. This means put it downstairs. Notice this is not a negative number. This is not a negative number. I know there's a negative number in it, but when we have a negative number as an exponent, it doesn't make this original number negative. You follow me? This is so important that I'm going to put a big star, and I'm going to say a negative number, a negative exponent does not make the entire number negative. That's up to the number. If the number's a negative number, fine. If it's not a negative number, it's going to remain not a negative number. Okay, let's try just a couple here. What if I want you to rewrite these without negative exponents. So how would you write 4 to the negative 6th? Let's try 7 to the negative 12th. And 1 to the negative 9th. Rewrite these three so that they don't have negative exponents. If you want to use what I have right above it as a model, that's fine, but I want you guys to understand why the model works. Okay, how'd we do with these? All right, so the first one, 4 to the negative 6th, is the same thing as 1 over 4 to the 6th. Notice, nothing is negative. Just because a number has a negative exponent doesn't mean the number itself is negative. Bless you. The second one, what does this become?
1 over 7 to the 12.
1 over 7 to the 12th, perfect. And what about the third one? Well, you might start off with 1 over 1 to the 9th, right, if I follow the same pattern that I did for the others. However, if you gave me this on your paper, I might dock you a half a point or so. Why would I do that? I might write minus half a point, and I might write the word simplify. Yeah, you know the answer to this. What is 1 to the 9th? 1. What's 1 divided by 1? 1. Your final answer here is 1. So, I don't expect you to know what 7 to the 12th is. I have no idea what 7 to the 12th is. But I do expect you to simplify any ones that you're able to do. So 1 to any power is always 1. Anything to the 0 power is 1. We talked about that. Same thing with like 4 squared. Don't write 4 squared because I know you know what that is. What's 4 squared? 16. So just write 16. When the numbers get excessively large, then no, you can leave them 4 to the 6th. That's a pretty large number. Leave it as 4 to the 6th. But if it was 4 squared, there's no reason not to write 16. Okay? So when the numbers are relatively small, please go ahead and do them out. But I mean, because they get large pretty quickly. Like even 3 to the 5th power gets pretty big pretty quick. Okay? Now, here's what I want to try. I'm going to mix negative numbers with negative exponents. Let's see how we do with these. Follow your order of operations. Be careful. So let's try a new set. Try these. What if I asked you to do -4 to the -6th, like that? I'll put a couple of them up and then we'll talk about them. I can fit one more. Thanks. So just try these 3. Okay, did everybody write down an answer for each? Okay, let's talk. So, the first one. Here we have a negative number being raised to a negative exponent. Is there anything to do inside the parenthesis? No, it's just a -4. So I want to raise a -4 to a -6 power. If it was 4 to the -6, you guys all know what to do. We just did that up here. 4 to the -6, I put 1 over 4 to the 6th. So I'm going to use the same rules. You just have to be very careful because you're dealing with negative numbers here. So I want this to be 1 over -4 to the 6th power, don't I? Okay, 1 over -4 to the 6th. Is that how I should write it? Is that how you wrote it? Well, if you wrote it that way, sorry, that's not how you write it. If you want to raise a negative number to a power, what do you have to have? Guys, if I want to write a negative number raised to a power, what do I need? Parentheses. If you still want to have -4 raised to the 6th power, you have to put it in parentheses. Does it make a difference? Yeah. It makes it kind of a big difference. Is everybody okay with what I've done so far? I followed the same pattern. Look what I did. We have the exact same problem here. It's just that in this case, it's a +4 that I'm raising to the -6, and here it's a -4 that I'm raising to the -6th. So, first thing I need to do is I need to put the number in the denominator and raise it to the positive power. So, everybody was fine when we did this. Here, I want to do 1 over negative 4 to the 6th. But the sooner we understand that any time you want to raise a negative number to an exponent, you have to use parentheses. It's an absolute must because it's going to be the difference between a positive and a negative. Okay? So, is everybody all right with where I'm at now? You can actually simplify this a little bit more. I don't expect you to know what negative 4 to the 6th power is. However, if you have a negative number and you raise it to an even exponent, what would the sign be? Positive. So, even though I don't know what 4 to the 6th is, but if I'm going to do negative 4 times 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 negative 4, I know that the sign will be positive. I have no idea what the number is going to be, but wouldn't the sign have to be positive? Yeah. So, this will actually be the same thing as 1 over positive 4 to the 6th. If that exponent had been negative, what would my sign have been? Then it would have been a negative. So a negative number raised to a negative exponent is going to give me a negative answer. But that's not what I had here. Okay. Let's try the second one. I'm going to draw a line here. Now, remember what I have to do. There's no parentheses here. No parentheses. So I have to do the exponents next. Guys, I'm telling you, this might be a very easy way for you to do these. If you have a problem like number 2 here, there's no parentheses. Cover that up. Do that. And then this just means take the opposite of what you have. So if I cover that up, what's 5 to the negative 7th? 1 over 5 to the 7th. And you guys are pretty good with that. 1 over 5 to the 7th. But now this means make it negative. So where do I put the negative? It actually doesn't matter. Remember, it's a fraction. You can put it on top, you can put it on the bottom, you can put it on the front. Just make sure it's somewhere. Now, in this case, is this final number positive or negative? It's a negative, right? The negative exponent didn't make the number negative. The number was negative to begin with. The negative exponent had nothing to do with it. That number happened to start off negative, so it stayed negative. Okay? And then the last one, be careful. What's this? Ooh. Ooh. It's not 1 over anything? No, this one doesn't have a negative exponent. I tried to trick you, but you guys are pretty good. Negative 10 squared. It's written in parentheses, so this really means negative 10 times negative 10, which is positive 100. So if you answered positive 100, you are correct. Okay, I know these are tough. The majority of this is just keeping track of your negatives. Okay? So, at this point, I'm going to give you guys a practice sheet to try. We're going to stop the video, so hopefully this